your talk, you described how the brain could be considered a machine, and how
Right.
Why not build from silicon instead of carbon? And then at one point you said, I don't see that artificial life will love. And I was right with you up until you made what appeared to me to be a U-turn. And then before I got my feet again, you switched the question to developing new portals for understanding the consciousness of all those around us. And I'm interested in definitely the new portals, but could you help me past that discontinuity from they play Go, they drive, how do you know they're not conscious, to, yeah, they're not going to love?
Right. So the question is, what assumptions are we making? Most of my colleagues are physicalists, and so they're assuming that what's fundamental in nature is space-time and quantum fields, particles, and their assumption is that those are fundamentally unconscious. So for them, the artificial intelligence question, could AI feel love, is the question, could unconscious foundational ingredients eventually give rise to conscious experiences, genuine love? That's their question. And what I'm saying is, if you pose the question that way, the answer, I believe, is no. You can't start with unconscious ingredients and boot up consciousness. However, I do think we will build conscious AIs. But the theoretical framework is different in the following sense. We're going to build them not by taking unconscious matter and getting it somehow to give the magic of consciousness. Instead, what we're going to be doing is using technologies like silicon and circuits and so forth, and other technologies that we're going to discover that come out as we really understand this realm of conscious agents. So, I mean, when I talk about a realm of conscious agents, I'm not intending to just have a hand wave. I'm intending to have a mathematically precise theory of a network of interacting entities with a dynamics that we can write down and study and analyze. That's the goal. A very rigorous dynamics, and a very mathematically precise relationship between that dynamics and what I'm calling our space-time interface. And the team that I'm working with, and a few members of the team are here, including Shanna Dobson, who's right in the front. We're working to have a mathematically precise model of the realm of conscious agents, what we call space and time as our interface, and the mapping. And then the goal is this. We know that our interface does give us portals into the realm of consciousness. Every person I see here is an icon that I'm creating. I mean, your body that I perceive is my creation. I close my eyes, the body that I perceive disappeared. Your consciousness doesn't disappear, but the body that I'm creating, when I open my eyes, that disappears. So the body that I see is my creation. Your consciousness is yours. So when I open my eyes and I see your body, I have a portal in my interface to your consciousness. And when I see a cat, again, the body that I see is just my icon in my interface. The consciousness behind it is there whether or not I see the cat body. So we know that our interface gives us portals into the realm of consciousness. And so I turn the question around. It's not, can we create consciousness from unconscious ingredients? It's rather, the consciousnesses are out there. We know we have portals to some of those consciousnesses. Very few, by the way, right? The theory says that there's an infinite variety of consciousnesses. We see a very, very small variety. So in terms of like physicalist notion of dark matter and dark energy, we don't know what's out there in the universe. Oh yeah, it's worse than that. It's far, far worse than that. Most of those conscious agents, we have no idea. We have access to a few. But I see no principled reason right now why a theoretical understanding of conscious agents, a theoretical understanding of our interface and how it works, would not allow us to reverse engineer our interface, and open new portals. I see no principled reason right now. There may be one. As we do the mathematics, we may find, but I don't see right now any principled reason why we couldn't. So I think that we will be able to devise what looks like AIs with consciousness. But it won't be unconscious ingredients becoming conscious. It'll be opening up new accesses to pre-existing consciousnesses. There's another aspect that I only had 20 minutes, so you have to do a straight line. We also, within our interface, have evidence that looks like we're seeing the creation of new consciousnesses. When we see reproduction in biology, whether it's sexual or asexual, that suggests in our interface that we're witnessing perhaps the birth of new consciousnesses. Now, we'll see what the mathematics says, but that's one possible interpretation, that we're seeing the genesis of new consciousnesses. If that's the case, then I think that it may be possible not only to have a technology that opens new portals into the realm of consciousness, but technology that will allow us actually to create new conscious agents as well. So that's the kind of thing I had in mind when I say that there's a Pandora's box ahead. We all know firsthand that not all conscious agents out there are friendly, so we'll see what happens. So there was a gentleman here.
Kurt Gödel,
Yes.
showed
Yes.
that in any mathematical system or in any significant system, that there was, I'll call it truth, which cannot be proved, but which is, as a matter of fact, true.
Right.
But you cannot prove it. And so you have to go outside whatever the system is
Right.
in order to access that, if you will. And I'm trying to get a handle of relating that to what you're saying. And in essence, I'm having a hard time framing this question, but it's something like, okay, I have a certain consciousness, and through my eyes, I can get a portal into your being, shall we say. But I'm not a higher consciousness than you are, or at least presumably I'm not. You're not a higher consciousness than I am, presumably. But the question is perhaps something like, where can wisdom be accessed? And maybe that relates to the Pandora's box. But where can wisdom be accessed? And I'll just be personal for a moment. I'm an addict. I must have a higher power in order to solve my addiction. Right. And as a matter of fact, there is a higher power through which I do solve my addiction. So there is some kind of truth, some kind of power, some kind of wisdom which comes into my life. And so and it has to do with Gödel, of course. So I'm wondering if you can comment on that.
Sure.
I hope I've made myself clear.
That's a great question on a couple levels. So Kurt Gödel made perhaps one of the greatest advances in human knowledge ever in the 20th century. Truly stunning. One of the most brilliant men ever. And his Gödel's incompleteness theorem was mind-blowing. Yeah, is that not loud enough? So what Gödel showed was that if you take any finite set of assumptions, axioms in a mathematical system, but you can also, I think about it as assumptions in a scientific theory. I'd like to apply it there as well. But strictly speaking, it was mathematics. So any set of axioms, you can look at the theorems that you could prove. And there's a collection of statements that you can prove that are true. But Gödel showed that there will always be truths that cannot be proven within that system using those axioms. And that was a shock because most mathematicians had hoped that we would be able to do mathematics as a mechanical, here's the axioms, now we can just grind out all the proofs. Now, So how does that relate to consciousness? I mean, that sounds like, well, this is just off in left field compared to consciousness. But when I propose, and my collaborators propose, that consciousness is fundamental, conscious agents are fundamental, and there's nothing else. That's the fundamental nature of reality, is consciousness and conscious agents. It turns out that when you study consciousness, and one of the things that I've done for decades is studied something called psychophysics. It's a branch of science where we study conscious experiences with careful experiments, and we write down mathematical models. Precise mathematical models about how you see in 3 dimensions, for example, how you see colors. And what we've discovered is that your conscious experiences of colors, shapes, motions, sounds, and so forth are not amorphous jello kinds of things. They're highly structured, and we can predict with mathematical precision what you will see, the precise conscious experiences that you will have in various situations. It's truly stunning. So we can write down mathematical models that will predict exactly when you will go from seeing something like moving dots, moving in only 2 dimensions, to when all of a sudden they pop out and you have a new 3-dimensional experience in consciousness. We can write down equations that precisely capture when you're going to go from a 2-dimensional conscious experience to a 3-dimensional conscious experience. So what we've learned is that consciousness is not amorphous, it's structured. It has precise mathematical structure. So, what is the relationship between mathematics and consciousness? I don't think that they're separate things. I think to be conscious, to be a conscious experience or a conscious agent, is to be structured. And so mathematics is not divorced from consciousness. It's if you might think of it as the bones of consciousness. It's the structure underlying consciousness. So mathematics is not an alien thing. It's an integral part of consciousness. Now, a big question about consciousness is, what is it about? Right? I'm getting rid of the Big Bang as the fundamental story and so forth. I'm saying consciousness is the fundamental thing. So that raises the question, okay, if the universe is a bunch of conscious agents, what are they up to? What's the dynamics about? Why? Right? There's some deep, deep questions. Here's where Gödel's theorem comes in. Well, the first answer is, I don't know. Right? Okay, that's I mean, just off the boat. All right. But now that I've said that, it's the role of a scientist to propose ideas that we can then make mathematically precise and test. And here's one idea based on Gödel's theorem. Gödel's theorem is telling us that no matter how many assumptions, how much structure you start with in a consciousness, there will always be more to explore. What Gödel is telling us is exploration of structure is endless, absolutely endless. And that's a stunning thing. There is no way, it's just impossible for any system to see all the structure that there is. So here's one idea, is that consciousness is, the dynamics is, hey, it's like a kid in a candy store. There's so much to explore, it's never ending, and so consciousness is just exploring all the different possible structures are the bones of new kinds of conscious experiences. All the structure that there is to explore is not just desiccated mathematics, it's living consciousness that's out there to explore. So I'm completely reinterpreting Gödel in a way that, of course, my physicalist colleagues would not. By saying that mathematics is the structure of consciousness, there's endless new structures out there. That means that consciousness has an endless suite of opportunities to explore, and that's what it's about. We'll see. I mean, but it's certainly a fun idea, and it's one that we can try to test. Now, in terms of a higher power, one thing that comes out of this theory of conscious agents, and of course, my talk today was only 20 minutes, so I said conscious agents, I didn't even tell you what I meant, right? I mean, but there are other talks that I've given here at SAND where I have actually the mathematics, and I did one yesterday as well where I go through the mathematics in some detail. So the notion of a conscious agent is absolutely mathematically precise. And we're working with Shanna to take it to a new level of sophistication. But right now it's precise. And the mathematics says that whenever 2 conscious agents interact, they combine to form a new conscious agent. That's the mathematics. I didn't expect, I mean, I wrote down the mathematical model myself. based on intuitions about consciousness, wrote down the mathematics, and it was only when I looked at them a few weeks later, looked at the mathematics, that I realized that it was saying to me that when agents interact, they create new agents. Now, they can interact in a way where the new agent is not much different from the original, what people call a Cartesian product. But they can also start to interact more so that the new agent really has new properties that aren't reducible to the two lower agents. And this can go recursively infinitely many times. So that means that there's an infinite network. That's why I talked about an infinite network of conscious agents. Agents are interacting, and whenever they interact, they create a new agent. So in some sense, there's an infinite network of conscious agents, but they're also all one agent. So there is one big agent. But there are also very, very simple agents. The theory allows, and therefore there must be, agents that have literally only like two experiences, like red and green. I call them one-bit agents. It's hard for us to imagine a conscious experience that austere, but the theory says it. As a scientist, I've got to go there and say, my imagination can't go there very easily, but the mathematics is forcing me to go there. When one-bit agents interact, they might form two-bit agents, four-bit agents, all the way to infinity. And so that allows me then to have, for the first time, a definition, probably wrong, but at least precise, of what we might mean by the word God. An infinite conscious agent. That might be God with a little g. There might be many infinite conscious agents. And if the mathematics shows that there is one supremum of this whole thing, that is the most inclusive, but Gödel's theorem may rule that out. That's the interesting thing. It's really interesting. But certainly there could be gods with a lower g that are infinite, and there could be infinitely many of them. So for the first time that I know of, we have a precise definition of God. It's probably wrong, but that's not the point. The point is to be precise so we can find out precisely where we're wrong. Now we can actually make progress, put something false but precise on the table. Now we can try to figure out why it's false, and that's how science moves forward. Until now, we've had the word God as just 3 letters. We say stuff about it, but it's never mathematically precise. Now we have a chance to actually be surprised. The thing about mathematics is when you write down the mathematics, it becomes smarter than you. The person who writes down the mathematics then becomes the student of their theory. When Einstein wrote down general relativity, he had no idea that it predicted black holes. And when he found it out, he didn't like it, and he disbelieved it. And the theory was smarter than him. And that's why we do mathematical models. I want my theory to slap me in the face and wake me up and shake my intuitions and go where I wouldn't have gone otherwise. That's why we do science. So this does, but one last thing and we'll move on. It does mean that there are agents above us, and I'll be very interested. So whenever 2 of us interact, there's a higher agent. I want to study with my team. Why is it that we don't see them? And does the mathematics predict why we don't actually see them typically? Are there ways that we might be able to see these higher agents, or are we precluded from seeing them by the mathematics? That would be very, very interesting. So there are higher powers, so to speak, and we will be able to model how they interact with us. And as we get an understanding of the dynamics, we may understand how higher powers, like in 12-step programs, are helping. I'm looking forward to doing that. It's a tall order, but I think we have a framework where we can try to do that. But not tomorrow. We have, and there's someone way in the back that we don't want to forget to, but yeah.
Here's the mic. Oh. Yeah, you spoke of that the theory beginning with consciousness as the singularity in a way, the fundamental essence, and I just wondered if there's a certain Buddhist concept of 3 truths, the ultimate reality, that are co-equal. The truth of temporary existence, which is all the physical stuff. The truth of non-substantiality, which would be consciousness and all that entails. And the truth of the non-dual reality of both of them simultaneously, right? The truth of the entity. So I wonder if it might not be useful to, because with consciousness only, you kind of get the mirror image of the hard problem.
Mm-hmm.
Where does matter magically appear out of consciousness? So, I'm sure you've pondered that.
Great.
So fundamental. But and then I have just one. I wonder if we might not already have in existence feeling or AIs that experience feeling in some way analogous to ours. We just don't have the interface to be aware of it. How about a jellyfish, for example?
Right.
And finally, one question. In the robot that performs such amazing acrobatic feats ending with a victory sign, do you know, is there any agency at any part of that performance, any volition on the part of that machine within that performance? Is entirely programmed ahead of time?
Right. Good questions. I'll just mention there are a lot of apparent relationships between the mathematical model that I'm proposing and various Eastern mystical traditions, like Buddhism and Hinduism and so forth. It's not to my credit that I wasn't influenced by those. My upbringing was, my dad was a fundamentalist Christian minister, and that was my upbringing. I'm recovering. And so as a result, I didn't have much exposure to those traditions. But since I've had the model come out, I spent a long weekend at the Krishnamurti Foundation in Ojai, and talking with mystics across the table. Very, very useful. My attitude is, as a scientist, I need to be open to get ideas everywhere. And in particular, these traditions have been exploring consciousness for thousands of years. And so surely there are pearls of wisdom there that my colleagues who are physicalists and scientists would not have been pursuing because of their physicalist framework. And so I think the mystics have been ahead of us for millennia in exploring it, and science will have to catch up. On the other hand, what science has is this very rigorous methodology. And so that's what I'm hoping to have, is the best of both. Get the insights from the spiritual traditions to help provide the intuitions to develop the theory further, and then the rigor of mathematics and predictions, where the goal is to show where you're wrong. As long as we're willing to say, here's my ideas, but of course I can be wrong, let's test it, then we're on the same page. That's the only time we're going to learn. If we say, this is what I believe and that's it, that's when you stop growing. And so that, for me, the fundamental attitude of science is to be precise so we can find out precisely where we're wrong, and that way we can grow. So I want to take the best ideas and assume that no idea is true, including my own. We take the ideas and we push them as far as we can until they break. And then when they break, by the way, it's not a failure. It's like, okay, now we're going to learn something new. So that's my attitude about it. Can you remind me about your question at the end then?
I wondered if that performance by that robot was entirely pre-programmed.
Right. So that robot is by Boston Dynamics. And the founder of that company is Mark Rabert. And he and I had the same advisor at MIT. Whitman Richards was our advisor. He was there a few years before me. And the way I believe that the current generation of robots is learning is, when I was there at MIT, we were trying to solve control system problems and actually build robots that worked by sophisticated mathematical modeling of control theory and so forth. So we had to be smart enough to build all the control in ourselves. And there was a lot of progress that was made on that, and that was one of the hardest classes I took at MIT, studying recursive Lagrangian dynamics of actuators. It was unbelievable. But now with deep learning, we can literally have the robot we give it, so this gets to your question, we can give it certain goals. Stand up, don't fall over. And it has a built-in penalty function. You know, if you fall over, you need to change your parameters. And what you can do is have a learning algorithm. So the robot, just like a baby, right? An infant is doing the very same thing. It doesn't know that this is part of its body, and it's hitting itself and doing all this. And eventually it figures out important stuff like, oh, I can control this, and I can hit my brother. That's really important. I mean, that's really good news. Now I can hit my brother, I can steal his toys. But we learn that through trial and error. And so that's what they're doing. So they give these robots some mini goals. Now it's not like my goal is to run a marathon or, you know, to help human beings. It's more, I don't want to fall over, I don't want to fall on my back. And those are the goals that you give it. And then what it does is the networks inside of it, you update the connections within the networks that get it closer and closer. And so we don't actually know why it works, because the network that's inside of it is really complicated. But the connection strengths are just right, so now it knows what to do. So there are these mini goals, but there's no reason why we can't build bigger goals into it. But now I'm using the word goal in a very, very different sense than like a human, where we have a feeling of a goal, felt conscious desires. That's a different thing. That, most of my colleagues who are physicalists, like Steven Pinker and so forth, or especially David Chalmers, would say, look, there's nothing more to a feeling than being the right algorithm. They're, in some sense, two sides of the same coin. So he would probably say that there is a sophisticated emotion in any goal that you put there. The problem I have with that is that we can't, as scientists, write down a mathematically precise theory that says this algorithm must be this feeling, the taste of chocolate. It could not be the smell of garlic. And these are the principled reasons why. Until my colleagues in the physicalist camp can do that, I'm not on board. That's the problem that they've got. So that's why I'm hard-nosed about it. And of course, these are my friends. The physicalists, we're all good buddies. But when it comes to this professional stuff, of course, then it's gloves off. We need to really, yeah. I don't know where the microphone is. Oh, yes, okay.
This is more of a personal question. With your longer range plans and the theories and the things you're working on, how do you deal with what I see as the strong possibility of climate catastrophe within a decade and that kind of thing? And so how do you integrate that into your life and what you're doing? And I remember at Esalen once you talked so personally about your life with Rupert Sheldrake, which I really appreciated. So I feel free to ask this question.
Right. Oh, that was quite a while ago, yes. It is scary what's happening here with the climate. And I have a number of reactions on a personal as well as a scientific. I mean, I have grandkids that I love very, very deeply, and on a personal level, I would hate to think about them living in a world that's devastated by the heat and storms and flooding and so forth and famine. So it is very personal that way. One field that I study is evolutionary psychology, and it's a very powerful scientific discipline that, for the first time ever, we have a scientifically precise theory that predicts the logic of human emotions and why we behave the way we do. It answers the why question. Why do we behave the way we do? Now, I'm not saying it's all right. I mean, this is, again, it's a scientific theory. There's going to be problems. But for the first time, there's a theory that actually tries in a systematic way to answer the why question. And that theory actually does explain a bit the logic of human emotions and why we're so short-sighted. One thing that comes out of evolution by natural selection is that we're trying to, it's in some sense an algorithm that maximizes your local fitness or satisfies your local fitness. But 99% of all species that have ever been on the planet are now extinct. Evolution by natural selection is very successful for a period of time, and then every species goes extinct. That's what the fossil record shows us. And I'm not saying this to be a downer or to be pessimistic. It's absolutely critical for us to understand human evolutionary psychology and why we are short-sighted, so that we can then try to change the message and the social institutions in our country and around the world to communicate to people in a way that they will actually engage with their evolutionary psychology and engage with their emotions, so that we will change our behaviors. So so my attitude about this as a scientist is, by understanding human nature and not turning our eyes away from it, there's another attitude, by the way, that says that humans can do anything. You know, you're not constrained by your biology. The sky is the limit. And I think we need to understand that there are evolutionary genetic constraints on us. We can rise above them, but it's not easy. And looking at that squarely, looking at human nature squarely, will help us to devise social institutions and political structures that will allow us to intelligently engage with human nature and be able to try to answer these kinds of political and environmental problems. So, yeah. Someone else is controlling the mic, but yeah.
Donald, we had a brief email exchange about the interview. My name's Joel.
Yes, Joel.
And I thought I would ask one of my questions now.
Sure.
And fundamentally, in your theory, the concept is that we're assembling truth not on the basis of objectivity, or we're assembling information that's very specific to the experience of fitness payoffs. I guess what I want to ask is that through evolutionary psychology, all these other humanity disciplines, religion, literature, if it's beyond our perceptions, could it help with, let's say, things like religious tolerance, if all of our religious beliefs are icons as opposed to objective truths that get us riled up? So could it be useful in that regards, like from a moral standpoint?
Thank you. I use evolution by natural selection a lot in my arguments, and I've just said a lot of nice things about evolutionary psychology. Now I'm going to completely change I don't believe any scientific theories, including evolution. It's the best theory we have so far, and so we need to use it. It's a beautiful theory, it's a very, very powerful theory, and I don't think it's the truth. But we don't have anything better. And it does give us far more insights than we've ever had before, so we've got to go with it right now. But as a scientist, I'm always looking for a deeper theory. I think that we will get a deeper theory of the evolution of consciousness. And in that realm, we may be able to see truths. I don't know. I'm hoping that we will be able to see truths in that realm. From the point of view of evolution by natural selection, it is a theorem that selection pressures are uniformly against us having true perceptions of objective reality. I've been working with Chetan Prakash and Chris Fields and a number of my collaborators on that. So if we just take the scientific theory of evolution by natural selection, it entails we will not see the truth. I'm looking for a deeper theory of the evolution of consciousness, which, when it projects into space and time, our space-time interface, it looks like evolution by natural selection in our interface. That's the goal. So evolution by natural selection will be a test for my deeper theory. If my deeper theory cannot give me back evolution by natural selection, then my deeper theory is probably wrong. And I need to revise it until I can show that it looks like evolution by natural selection. So it may be the case at a deeper level that we can see truths. And I'm hoping that's the case. But still, to your point, the fact that we are deceived here, and evolution by natural selection makes it very, very clear that deception is not the exception, it's the rule. And it's not only humans that deceive and lie, but orchids lie to bees. And they shape themselves to look like beautiful females. And the male bees try to mate, and they just get frustrated. They get a little pollen, and they go off to another orchid and try to mate, and they pollinate. So they're being used. And this is not the exception. It's the rule throughout nature that we have these interfaces that are finite, right, because we can't deal with all of the reality. And that means that you will have vulnerabilities because you don't see everything. You don't see the truth. And so evolution, you can think about biology and evolution as really one organism trying to exploit the weaknesses in the interface of another, and then that that organism doesn't respond properly, it goes extinct. But if it can, its interface evolves, and it might then counter. And so you have this arms race among interfaces. So it's in that context of understanding lies and so forth that we can then begin. First, we have to face that. We can't turn our heads away and say, that's ugly, it's horrible. I mean, we have to face that because in our social and political systems, that's what's programmed into us. And so if we don't look at that, we will not make the right moves. You have to look at the hard, cold facts before we can make good policy decisions to counter. Yeah.
I was fascinated by the title of your talk, which was, Can AI Feel Basically Human Emotion and Feelings? And from the evolutionary standpoint, I thought that was maybe beside the point, because emotions are things that animals are evolved to feel to survive. And emotion, Latin, move away from things. It's the thing that makes you move. And strictly speaking, an AI doesn't need to move, doesn't need to survive, so it has completely different selection pressures, if you will. So the two-pronged question is, one, is there a point even thinking about that question in terms of for AIs? And two, are we short-shrifting silicon that could have a much richer, more interesting experience of human emotion that we don't even recognize as emotion?
Right. So good on 2 points there. The 2 points being that emotions for animals really are guiding their activities to survive, and if we don't have those same kind of drives in in AIs, maybe we're shortchanging them. Our AIs heretofore have had very limited goals built into them, but there's a new wave of AIs coming. There's a new framework that many are adopting in which the idea is to give them intrinsic goals. There's some work being done at USC on this, for example, University of Southern California. And the idea is to give richer and richer sets of goals and to also make the AIs fragile. Not make them made out of invulnerable metal, but to make them fragile such that if they don't behave properly, they will actually suffer and they will be injured, and to give them circuit feedback of their injury. And in that way, they'll be forced to learn goals, and they will learn like we do. As little children are crying all the time because they bump into things, they try stuff, and it hurts. And as adults, that doesn't happen to us very often. We learned what not to do as children. But children is really, really tough. They hurt all the time because they're learning. The idea is to do the same thing with robots. And so there's a new generation of robots that's going to be coming out, I believe, that will do this kind of thing. Now, but the question is, from the physicalist framework, will they really be feeling? Right. So now I'm putting on the science hat now. My colleagues who say that the fundamental circuits in software are not conscious, they have to explain how building in these new algorithms that say, don't do things that will break this limb, don't do things that will make you fall on your head and so forth. How does that kind of software turn into a feeling? And if from their framework, they need to give me a mathematically precise explanation about exactly what program is what feeling. And I don't think they'll ever be able to do it. Now, I'll also point out on the emotions of animals. My physicalist colleagues have a real problem that they have to explain, and that is, why did consciousness evolve? From an evolutionary point of view, right? Why would natural selection favor organisms with conscious experiences? Why can't I just go through life finding, what works and doesn't work without having any feelings? You could imagine a robot that just gets feedback from an environment without having any feelings, just has these sensors but no experiences, and does the whole thing in the dark without any conscious experiences. Why did consciousness evolve? And it turns out that there are no good answers to that problem at all. None of my colleagues have a good explanation. They'll say things, well, like when you're in a novel situation and you need to explore a lot of different possibilities, that's what consciousness is for. Well, I can write search algorithms without assuming consciousness, and they can explore widely. That doesn't explain anything. And another problem they've got is most of my colleagues who are physicalists want only physical objects and entities to have causal powers. They need a causally closed physical universe. If they say that there is something called consciousness that evolved, consciousness itself cannot have any new causal powers over and above the physical system that it's in. If it did, that would be a non-physical new entity into the universe, and now physicalism is no longer a physicalism, it's a dualism. So they don't want that. So here's the problem. Consciousness itself cannot do something new. It cannot itself have any causal powers. But if consciousness has no causal effects, then it can't be selected for. There's nothing for evolution by natural selection to operate on. So if consciousness is somehow being given rise to by your body, but consciousness itself can do nothing, then there would be nothing for evolution by natural selection to do to actually choose those creatures that have consciousness over those that don't. So there would be no selection pressures. So my colleagues have a real nasty problem. They can't solve it. They have no way to figure out how biology could give rise to consciousness, and if it gave rise to consciousness, they have no idea how natural selection could shape it. It could not shape it. So evolution by natural selection could not shape the kind of consciousness they want that has no causal powers. So they're in trouble. That's why I switched. By the way, I was a physicalist. It just didn't work. I had to move around. I switched to consciousness out of desperation.